Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC equals to 30 units, angle ACB equals to 100 degrees, angle ABC equals to 30 degrees, angle ACB equals to 100 degrees. And we also know that side AD equals to side BC, and we want to find out the value of this angle, angle ADC. So we will start with the first method. We will define side AC as A, that is to say the length of side AC is A units, and we will define side BC as B. That is to say, the length of side BC is equal to B units. According to what is given us in the question, we know that AD equals to BC, but according to our definition, BC equals to B. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. So we write down here that AD equals to B. In the next step, I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle. So in any triangle, if we have triangle ABC, that could be any triangle. So this is triangle ABC. And we know that side BC of triangle ABC equals to A units in its length. This is angle A. And we also know that side AC equals to B units in its length. This is angle B. And side AB of triangle ABC equals to C units in its length. And this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. I'll write it down. A over sine A equals to B over sine B equals to C over sine C. This formula is true in any triangle. From this formula, we will derive that A over sine A equals to B over sine B. And we will implement the law of sines in our triangle ABC. So I will copy triangle ABC in the new page, and we will implement the law of sines in this triangle ABC. So this is triangle ABC that I copied from the original image, from the original drawing. We know that side AC equals to A units, side BC equals to B units, angle ABC equals to 30 degrees, angle ACB equals to 100 degrees. And first of all, we will find out the value of the missing angle. That is to say, we will find out the value of angle BAC that we will define as angle X. We know that the sum of the angles in any triangle is equal to 180 degrees. And especially the sum of the angles in triangle ABC must be equal to 180 degrees. That is to say, angle X plus 100 degrees plus 30 degrees must be equal to 180 degrees according to the rule that I mentioned. Here we will subtract 130 degrees from this equation and we will get that the value of angle X is equal to 180 degrees minus 130 degrees is 50 degrees. So we found out that angle X equals to 50 degrees. I will substitute angle X by 50 degrees. In the next step, we will implement the law of sines in this triangle, triangle ABC. According to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. So here we will divide equation number 1 by B and then we will multiply it by sine 30 degrees and we will get that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. In the next step, we will focus on triangle ADC, this triangle. First of all, we've already found out that angle BAC equals to 50 degrees. So if we define angle BAD as theta, then angle DAC will be equal to 50 degrees minus theta. Because if you subtract from this angle that is 50 degrees angle theta, you will get angle DAC that will be equal to 50 degrees minus theta. So I will copy triangle, but first of all we will find out the value of angle ADC, the angle that we are looking for. So I will define angle ADC as Y, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle ADC, the sum of the angles must be equal to 180 degrees. So angle Y plus 100 degrees plus this angle that equals to 50 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 150 degrees from this equation and we will get that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So here we will subtract, we will add to this equation theta, and we will get that angle y equals to 30 degrees plus theta. So the angle that you are looking for, that is angle y, equals to 30 degrees plus theta. So I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. So this is triangle ADC that I copied from the original drawing. AC equals to A units, AD equals to B units. Angle CAD equals to 50 degrees minus theta. Angle ADC equals to 50 degrees plus theta. And this angle ACD equals to 100 degrees. It is given us in the question. So according to the law of sines, we will get that A over sine 30 degrees plus theta equals to B over sine 100 degrees. So here we will divide the equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. This is according to equation number 2, but according to equation number 1, we've already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two expressions for A over B. Therefore, we will create equation number 3 that states that A over B according to equation number 1 equals to A over B according to equation number 2. A over B according to equation number 1 is equal to sinus 30 degrees over sinus 50 degrees. And it equals to A over B according to equation number 2. A over B according to equation number 2 is equal to sinus 30 degrees plus theta over sinus 100 degrees. So here we will cross multiply this equation number 3, and we will get that Going to equation number 3. First of all, we know that sinus 30 degrees is 1 over 2 times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we will use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosinus a we'll use this trigonometric identity in order to calculate the value of sinus 100 degrees. And according to this trigonometric identity, we will get that sinus 100 degrees equals to 2 sinus 50 degrees cosine 50 degrees. And it equals to sinus 30 degrees plus theta times sinus 50 degrees. Here 2 over 2 is 1, so 2 will get cancelled, and we have sinus 50 degrees in both sides of equation number 3, so sinus 50 degrees will also get cancelled, and we left only with cosine 50 degrees that equal to sine 30 degrees plus theta. Here we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. We'll use this trigonometric identity in order to calculate the value of cosine 30 degrees, of cosine 50 degrees. According to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we will substitute cosine 50 degrees in this equation, equation number 3, by sine 40 degrees, and we will get that, according to equation number 3, sine 40 degrees equals to sine 30 degrees plus alpha plus theta sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. We will subtract from equation number 3 30 degrees, and we will get that Angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees. So here theta equals to 10 degrees. But the angle that we are looking for, it is actually angle ADC that equals to 30 degrees plus theta, and theta is 10 degrees, so 30 degrees plus 10 is 40 degrees. So we found out that the angle that we are looking for, that is actually angle ADC, it equals to 30 degrees plus theta, it actually equals to 40 degrees. So the answer to the question is that angle ADC equals to 40 degrees. This angle ADC equals to 40 degrees. And so we finished with the first method. In the next step, I will present to you how to find out the value of angle ADC according to the second method. In the second method, we will define side BC of triangle ABC as A, that is to say BC equals to A units in its length, and according to what is given us in the question, AD equals to BC. AD equals to BC according to what is given us in the question from one side, but from the other side, according to our definition, BC equals to A. So from this equation, we will derive that AD also equals to A. AD equals to A. Okay, AD equals to A. In the next step, we will extend side BC by a straight line. And then from point A, we will draw perpendicular to the extended BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will define the intersection point between the extended BC and between the perpendicular from point A as point E. I repeat again. The intersection point between the perpendicular from point A and the extended BC is defined as angle as point E. And in the next step, we will define side AE as Y, and we will define side CE as X. Okay? And we will find out the value of this angle, angle ACE, that is actually, so we will define it as Y, and we know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And then after we extended the straight line BC by a straight line, we got line segment BE, that still will be a straight line. So we can write down that BE is a straight line segment BE is a straight line. BE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. That is to say, what angles we have at point C at the upper side of line segment BE, we have 100 degrees and also angle Y. Therefore, 100 degrees plus the size of angle Y equals to 180 degrees according to the rule that I mentioned. Here we will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees equals to 80 degrees. So we found out that angle Y equals to 80 degrees. I will substitute angle Y by 80 degrees. So in the next step, we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that tangents 80 degrees will be equal to AE over CE. AE over CE. I repeat again. On the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. And according to our definition, AE equals to Y and CE equals to X. Therefore, in conclusion, tangents 80 degrees in triangle ACE will be equal to Y over X. I will repeat again. Tangents 80 degrees in triangle ACE will be equal to Y over X. Here we will multiply equation number 1 by X, and we will get that according to equation number 1, Y equals to X times tangents 80 degrees. In the next step, we will focus on the right triangle, triangle ADE, and we will define angle ADE, the angle that we are looking for, as angle theta. So on the right triangle, triangle ADE, sinus theta equals to AE over AD. I will repeat again. On the right triangle ADE, sinus theta equals to AE over AD. AE equals to Y according to our definition, and we've already found out that AD equals to A. So, in conclusion, sinus theta in triangle ADE will be equal to Y over A. I will repeat again. In the right triangle ADE, sinus theta will be equal to Y over A. Here we will multiply equation number 2 by A, and then we will divide it by sinus theta, and we will get that according to equation number 2, A equals to Y over sinus theta. But according to equation number 1, Y equals to X times tangent 80 degrees. So we'll substitute Y by X times 80 degrees in equation number 2, and we will get that according to equation number 2, A equals to X tangent 80 degrees over sinus theta. And Y equals to X times 80 degrees. In the next step, we'll focus on the right triangle ABE. On the right triangle ABE, we know that tangent 30 degrees equals to AE over BE. I repeat again, in the right triangle ABE, tangent 30 degrees equals to AE over BE. But according to our definition, AE equals to Y, and BE equals to A plus X. So in conclusion, according to equation number 3, tangents 30 degrees equals to Y over A plus X. I repeat again. In triangle ABE, according to equation number 3, tangents 30 degrees equals to Y over A plus X. And according to equation number 1, Y equals to X times tangent 80 degrees. And according to equation number 2, A equals to X times tangent 80 degrees over sinus theta. So I will substitute A and X in equation number 3 by the values that we found for them in equation number 1 and equation number 2. So I will do it now, and we will get that tangent 30 degrees equals to Y is X tangent 80 degrees according to equation number 1 over A plus X, and A according to equation number 2 is X times tangent 80 degrees over sinus theta, and we also have to add here x, so we will actually multiply x by sinus theta and then we will divide it by sinus theta, so we change nothing, it still will be x. So here we will move sinus theta from the denominator to the numerator, and we will get that according to equation number 3, tangent 30 degrees equals to x tangent 80 degrees times sinus theta over x tangent 80 degrees plus x sinus theta. Okay, so here we have x in the numerator and we have x also in the denominator, so x will get cancelled. And we also know that tangent 30 degrees equals to 1 over square root of 3 units, so I write it down. So according to equation number 3, we will get that tangent 30 degrees is equal to 1 over square root of 3 units, and it equals to tangent 80 degrees plus times sinus theta over tangent 80 degrees plus sinus theta. Okay, so I repeat again. According to equation number 3, we got that 1 over square root of 3 units equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we will cross multiply equation number 3 and we will get that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta. So here we will subtract sinus theta from this equation, equation number 1, and we will find out that tangent theta, according to equation number 3, tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Here we will take out sinus theta as a common factor on this side of equation number 3, and we will get that according to equation number 3, tangent 80 degrees equals to sinus theta was taken as a common factor on this side of equation number 3. So inside the brackets, what is left from square root of 3 times tangent 80 degrees times sinus theta, what is left? It is actually square root of 3 times tangent 80 degrees. And we have also minus sinus theta, so what is left from minus sinus theta after we took from it sinus theta as a common factor? What is left from it? It is actually minus 1. So here we will divide the equation number 3 by square root of 3 times tangent 80 degrees minus 1, and we will get that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. We know that tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees. So we'll substitute tangent 80 degrees in equation number 3 by sinus 80 degrees over cosine 80 degrees. And we will get that according to equation number 3, sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. Divided by square root of 3 tangent 80 degrees. Again, tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. So here we will substitute minus 1 by cosine minus cosine 80 degrees over cosine 80 degrees. So here we have cosine theta in the cosine 80 degrees in the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees, what is left is actually in this side of the equation we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. So here we will multiply the denominator by 2 and then we will divide it by 2, and we will get that sinus theta equals to sinus 80 degrees over, I repeat again, we will multiply the denominator by 2, so it will be 2 times square root of 3 times sinus 80 degrees. So we will divide it by 2, which will be square root of 3 over 2, minus cosine 80 degrees. We will also divide it by 2. So we got that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees, and we will substitute square root of 3 over 2 by cosine 30 degrees minus, we will substitute 1 over 2 by sine 30 degrees. So we got that sinus theta equals to sinus 80 degrees over 2 times. Here actually the expression sinus 80 degrees cosine 80 degrees minus sinus 30 degrees minus time sine 80 degrees cosine 30 degrees minus sine 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B. In our expression, in our specific expression, sine A minus B will be equal, A equals to 80 degrees and B equals to 30 degrees, so sine 80 degrees will be equal to sine 80 degrees minus 30 degrees. Okay, so in conclusion we got that sine theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees, so I write it down. We will get that sine theta equals to sine 80 degrees over 2 sine 50 degrees Actually, according to the trigonometric identity, that sine 2a equals to 2 sine a cosine a, we will get that the value of sine 80 degrees is equal to 2 sine 40 degrees times cosine 40 degrees okay, so and we must divide it by 2 sine 50 degrees. So in conclusion, we got that according to equation number 3, sine theta equals to 2 sine 40 degrees cosine 40 degrees, because this is the value of sine 80 degrees. And in the denominator we have 2 sine 50 degrees. According to the trigonometric identity, that sinus alpha equals to cosine 90 degrees minus alpha, we will get that the value of sine 50 degrees is actually equals to cosine 90 degrees minus 50 degrees. Okay, so sine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees, so it equals to cosine 40 degrees. We found out that sine 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sine 50 degrees in equation number 3 by cosine 40 degrees. So we will do it now. And we will get that according to equation number 3, sine theta equals to 2 sine 40 degrees cosine 40 degrees over 2 sine, and we will substitute sine for 50 degrees by cosine 40 degrees. So we actually found out that sine theta equals to 2 sine 40 degrees cosine 40 degrees. 2 over 2 is 1, so 2 will get cancelled. We have cosine 40 degrees in the numerator and we have cosine 40 degrees in the denominator, so cosine 40 degrees will also get cancelled. And according to equation number 3, sinus theta equals to sinus 40 degrees. Sinus theta equals to sinus 40 degrees means that theta equals to 40 degrees. So we found out that angle theta equals to 40 degrees. This angle theta equals to 40 degrees. And this is actually the angle that we are looking for. It means the angle ADC equals to 40 degrees. So we found out that angle ADC, the angle that we are looking for, is equal to angle theta that equals to 40 degrees. So in both methods, we found out that the value of angle ADC equals to 40 degrees. So in the next step, I will summarize the lecture. Actually, we wanted to find out the value of angle theta in the first method. We defined side AC as A and side BC as B. According to what is given us in the question, AD equals to BC. But according to our definition, BC equals to B. From this equation, AD equals to BC equals to B, we will derive that AD equals also to B. So we can write here that AD equals to B. Then I presented to you the law of sines. The law of sines is true in any triangle. So if we have triangle ABC, that could be any triangle. In triangle ABC, we know that side AB equals to C units, side AC equals to B units, and side BC equals to A units. This is angle A, this is angle B, and this is angle C. According to the law of sines, we will get that A over sine A equals to B over sine B equals to C over sine C. And it is true in any triangle. From this formula, we will derive that A over sine A equals to B over sine B. This is the law of sines, and we implemented the law of sines in triangle ABC. So I copied triangle ABC in a new page, and we implemented the law of sines in this triangle ABC. First of all, we found this angle. We defined this angle as angle X. According to the rule that the sum of the angles in any triangle equals to 180 degrees, the sum of the angles in triangle ABC equals to 180 degrees. That is to say, angle X plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we found out that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So angle X equals to 50 degrees. Okay, then we implemented the law of sines in this triangle ABC. According to the law of sines, A over sine 30 degrees equals to B over sine 50 degrees. Okay, and here we divided the equation number 1 by B, and then we multiplied it by sinus 30 degrees. And we found out that A over B, according to equation number 1, equals to sine 30 degrees over sine 50 degrees. Okay, then we focus on the right, on triangle ADC. This triangle ADC. But before that, we just right now found out that angle BAC, this angle equals to 50 degrees. So if we define angle BAD, this angle as angle theta, then 50 degrees minus theta will give us the value of this angle, that is actually 50 degrees minus theta. That is to say, angle DAC equals to 50 degrees minus theta. Then we defined this angle, the angle that we are looking for is angle y, and we know that the sum of the angles in triangle ADC must be equal to 180 degrees. That is to say, angle y plus this angle that is equal to 100 degrees plus this angle that equals to 50 degrees minus theta must be equal to 180 degrees. Angle y plus 100 degrees plus this angle that is 50 degrees minus theta must be equal to 180 degrees in triangle ADC. Here we subtracted 150 degrees from this equation, and we found out that y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So y minus theta equals to 30 degrees. And here we added theta to this equation, and we found out that angle y equals to 30 degrees plus theta. So the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. Then I copied triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. This is triangle ADC. We know that angle DAC equals to 50 degrees minus theta, angle ACD equals to 100 degrees. It is given us in the question, and we just found out that angle ADC equals to 50 degrees plus theta. So we implemented the law of sines in this triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Okay, A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. We divided this equation number 2, by B, and then we multiplied by sinus 30 degrees plus theta, and we found out that according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2, but according to equation number 1, we have already found out that A over B equals to sinus 30 degrees over sinus 50 degrees. So we have two expressions for A over B. Therefore, we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So, according to equation number 3, A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2, that is actually sinus 30 degrees plus theta over sinus 100 degrees. Here we cross multiplied this equation number 3, and we know that sinus 30 degrees is 1 over 2. So sinus 30 degrees is 1 over 2. 1 over 2 times sinus 100 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we use the trigonometric identity that states that sinus 2a equals to sinus a cosine a, and use this trigonometric identity in order to find the value of sine 100 degrees. According to this trigonometric identity, the value of sinus 100 degrees equals to 2 sinus 50 degrees times cosine 50 degrees. That equals to sine 50 degrees plus theta times sine 50 degrees. Here 2 over 2 is 1. And we have sinus 50 degrees in both sides of equation number 3. So sine 50 degrees will get cancelled. And we left only with cosine 50 degrees. That equals to sine 30 degrees plus theta. According to the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, we will get that the value of cosine 50 degrees must be equal to sinus 90 degrees minus 50 degrees according to this trigonometric identity. 90 degrees minus 50 degrees is 40 degrees, so we found out that cosine 50 degrees equals to sine 40 degrees. Okay, so here we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees because they are equal to each other. We did it and we got that sine 40 degrees equals to sine 30 degrees plus theta. Sine 40 degrees that equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. So we subtracted 30 degrees from this equation number 3, and we found out that angle theta equals to 10 degrees. Angle theta equals to 10 degrees. But the angle that we are looking for is angle ADC that equals to 30 degrees plus theta. So the angle that we are looking for, that equals to 30 degrees plus theta, will be equal to 30 degrees plus 10 degrees. That is to say the angle that we are looking for, angle ADC, equals to 40 degrees. Okay, so we finished with the first method. Then I presented to you how to find out the value of angle ADC according to the second method. In the second method, we defined side BC of triangle ABC as A. According to what is given as the question, AD equals to BC. But according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. So we can write here that AD equals to A. In the next step, we extended side BC by a straight line. And then from point A, we drew perpendicular to the extended BC. And we defined the intersection point between the perpendicular from point A and the extended BC as point E. And we also defined side AE as Y and side CE as X. Then we found out the value of this angle. First of all, we know that BC is one side of the triangle ABC, therefore it is absolutely a straight line. And then when we extended the straight line BC by a straight line, we got line segment BE that still must be a straight line. So we know that line segment BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So this angle, that is angle Y, plus 100 degrees must be equal to 180 degrees. 100 degrees plus the missing angle, that is angle Y, must be equal to 180 degrees. We subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees. That is to say, angle Y equals to 80 degrees. So this angle Y equals to 80 degrees. Then we focus on the right triangle, triangle ACE. On this right triangle, we know that tan 80 degrees equals to AE over CE. On the right triangle ACE, tan 80 degrees equals to AE over CE. But AE equals to Y according to our definition, and CE also equals to Y according to our definition. So, in conclusion, we found out that tan 80 degrees equals to Y over X. Here we multiplied equation number 1 by X, and we found out that Y equals to X times 80 degrees. Then we focused on the right triangle, triangle ADE, and we defined angle ADC, the angle that we are looking for is angle theta. So in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. In the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. AE equals to Y, according to our definition. And AD equals to A. We just found out that AD equals to A. So in conclusion, we found out that sinus theta equals to Y over A. Here we multiplied the equation number 2 by A, and then we divided by sinus theta, and we got that A equals to Y over sinus theta. Okay? But Y, according to equation number 1, equals to X times 80 degrees. So we substitute Y by X times 80 degrees, and we get that A equals to X times tan 80 degrees over sinus theta. Then we focused on the right triangle, triangle ABE. On the right triangle, triangle ABE, tan 30 degrees equals to AE over BE. I repeat again. On the right triangle, triangle ABE, tan 30 degrees equals to AE over BE. AE equals to Y according to our definition. And BE equals to A plus X. So in conclusion, we found out that in triangle ABE, tan 30 degrees equals to Y over A plus X. y equals to x times sinus 80 degrees according to equation number 1. A equals to x times sinus 80 degrees over sinus theta according to equation number 2. So we substituted y and a in this equation, equation number 3, by the values for y and a that we have in equation number 1 and equation number 2, and we got that sinus 30 degrees equals to y, that is x times 80 degrees according to equation number 1 over a plus x, and a according to equation number 2 is x times sinus 80 degrees over sinus theta plus x. Actually we multiplied x by sinus theta and then we divided by sinus theta, so we changed nothing. And here we moved sinus theta from the denominator to the numerator, and we got sinus 30 degrees equals to x times sinus 80 degrees times sinus theta over x sinus 80 degrees plus x sinus theta. Here we have x in the numerator and we have x also in the denominator, so x will get cancelled. And we also know that tangent 30 degrees equals to 1 over square root of 3 units. So in conclusion, we found out that according to equation number 3, tangent 30 degrees equals to 1 over square root of 3 units. That equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we cross multiply this equation, equation number 3, and we got that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta. Here we subtracted sinus theta from this equation, equation number 3, and we got that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Here we took sinus theta as a common factor from this equation, equation number 3, and we got that tangent 80 degrees equals to sinus theta is a common factor, so inside the brackets what is left is square root of 3 times tangent 80 degrees minus 1. Here we divided equation number 3 by square root of 3 times tangent 80 degrees over 1, and we got that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. Here we substituted tangent 80 degrees by sinus 80 degrees over cosine 80 degrees. And we got that sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees over square root of 3 times tangent 80 degrees. Again we substituted tangent 80 degrees by sinus 80 degrees over cosine 80 degrees. And we substituted minus 1 by minus cosine 80 degrees over cosine 80 degrees. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. What is left from equation number 3 after we cancel cosine 80 degrees? What is left is actually in this side of the equation we have only sinus theta, and in the other side of the equation we have sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. Then we multiplied the denominator here by 2 and then we divided by 2, and we got that sinus theta equals to sinus 80 degrees. Over here we multiplied by 2, so it is 2 times square root of 3 times sinus theta times sinus 80 degrees. Here we divided by 2, so it is over 2 minus cosine 80 degrees, we divided by 2 over 2. So we multiplied it by 2 and then we divided by 2, so we changed nothing. And then we got that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees. This expression is very similar to the trigonometric identity that states that sinus A times cosine B minus sinus B times cosine A equals to sinus A minus B. So we can substitute our expression by sinus A minus B. And in our specific expression, A equals to 80 degrees and B equals to 30 degrees. So sinus A minus B means that is sinus 80 degrees minus 30 degrees. Okay? And 80 degrees minus 30 degrees is 50 degrees. So in conclusion, we found out that sinus theta equals to sinus 80 degrees over 2 times sinus 50 degrees. Then we use the trigonometric identity that states that sinus 2a equals to 2 sinus a cosine a in order to find out the value of sine 80 degrees. According to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sinus 40 degrees cosine 40 degrees. So in conclusion, we found out that sinus theta equals to 2 sinus 40 degrees cosine 80 degrees over 2 times sinus 50 degrees. Then we used the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So in conclusion, we found out that sinus 50 degrees equals to cosine 40 degrees. That is to say, we can substitute sinus 50 degrees in equation number 3 by cosine 40 degrees. So we did it, and we got that sinus theta equals to 2 sinus 40 degrees cosine 40 degrees over 2 times, again we substituted cosine sinus 50 degrees by cosine 50 degrees. So here we have cosine 50 degrees. 2 over 2 is 1, so 2 will get cancelled. Cosine 40 degrees over cosine 40 degrees is 1, so 2 cosine 40 degrees will also get cancelled, and we left only with sinus theta that equals to sinus 40 degrees. Sinus theta equals to sinus 40 degrees means that theta equals to 40 degrees. So we found out that theta equals to 40 degrees, so the angle that we are looking for, that is actually angle ADC, equals to theta, and theta equals to 40 degrees. So we found out that the angle that we are looking for, that is angle ADC, equals to theta, and theta equals to 40 degrees. Therefore, we found out that in both methods, the angle that we are looking for, that is angle ADC, equals to 40 degrees. Okay? Thank you very much.